this question we're asked to express 3 cosine x plus sine x in the form r cos x subtract alpha, r bigger than 0 and alpha between 0 and 90. Same old stuff. 3 cosine x plus sine x needs to be written in this form, r cosine x subtract alpha. Expanding this using the addition formula, this would be r cos x cos alpha, add r sine x sine alpha. Just be careful there to look in your formula booklet. When it's cosine of a subtract b, you get a plus here when you expand the addition formula. So what can we deduce from this here? We can deduce two things. The coefficient of cosine is 3. So 3 must equal r cosine alpha. The coefficient of sine x is a hidden 1 there. There's a hidden 1, it's 1 sine x. Okay, so therefore we can deduce that 1 must equal r sine alpha. Okay, so let's write those deductions down. So we can say that r sine alpha is equal to 1, and we can state that r cosine alpha is equal to 3, and hence we can now find our r and our alpha. How can we do that? Well, r is always the square root of this squared plus this squared, so 3 squared add 1 squared, which is going to be the square root of 10. So r is going to equal the square root of 10. And if we divide these equations, we would get that tan alpha is a third. So alpha is the inverse tan of a third. Calculator out, inverse tan, 1/3. 18.4 degrees. Okay, so alpha is 18.4 degrees. Okay, don't forget to actually write your thing out fully at the end. So 3 cosine x plus sine x is therefore can be written as the following. Well, it can be written as the square root of 10 cosine of x subtract 18.4. And we've done here for our 4 marks. Then it says, hence or otherwise, use your answer to part A to solve the following equation. Give your answer between 0 and 360. Okay, I've actually copied this down here. Now, when I look at this, the first thing I think of is, okay, that doesn't look anything like anything I've done above. Alright, so, but obviously, it says using your answer to part A, so I'm going to have to make it look like above. But the problem is, I've got a single x here and 2 x's here. So, I should convert into all of them into single x's. That would be the best thing to do. Now, you should know your double angle formula. You know that sine 2x is equal to 2 sine of single x cosine of single x. So we can use that here to replace this by this. So we could write that 6 cos squared x plus 2 sine x cosine x is equal to 0. Solving that is equivalent to solving that. I can now factorise a factor of 2 and a cosine from both. So I can factor out 2 cosine x, and then I'd be left with 3 cosine x plus a single sine x is equal to 0. Now, that now does look very familiar. That's what we were dealing with in part A. So I've got 2 things that could equal 0. So either 2 cosine x is equal 0, or 3 cosine x plus sine x is equal 0. This one's easy to solve. Divide both sides by 2. Cosine x is 0. Inverse cos both sides. So x is the inverse cos of 0. Calculator out. Inverse cos 0, 90 degrees. So x is going to be 90 degrees. Let's check what other values we could have. We're looking in between 0 and 360. The cosine graph looks like this. So we know 90 is one of our answers here, that's 180, and this is 270. So our other answer is 270. So we can straight away write 270 degrees. What about this? Well, in order to solve that equals 0, let's use our r cos method. This was root 10, wasn't it? Cosine x subtract 18.4. Cosine of x subtract 18.4, that being 0. Divide both sides by root 10, so cosine x subtract 18.4 is equal to 0. Inverse cosine both sides, so x subtract 18.4 is going to be equal to 90, and the 270, same as before. So adding the 18.4 on, x is going to be equal to 108.4. or x is going to be equal to 288.4. And they are all our answers. So state them at the very end in order. X is 90 degrees, or it's 108.4 degrees, or it's 270 degrees, or it's 288.4 degrees, and we're done. Now, just looking up at the original question, I could have converted this to double angles and I would have still been able to get the same answer. I should know that cos of 2x is equal to 2 cos squared single x subtract 1. So cos squared single x is cosine 2x add 1 over 2. Now, if I substitute that in here, I would have been able to again solve it using, I would have been able to use this identity but with 2 x's instead of single x's. But for me, this one's way easier and that would have been more complicated. But we're done now.